Hello students, this is Mr. Allen, and today we are going to look at section 10.7, which is on areas of circles and sectors. Our objective here is to find the area of a circle, the area of a sector, or the segment of a sector. So first let's start with area of a circle, which you're probably already familiar with. The area of a circle is simply pi r squared. So in this easy example here, we can see that the radius is 2.5. So the area is simply going to be pi times 2.5 squared. That would be 6.25 pi, and that's it. So, if you need to use your calculator to find 2.5 squared, you can. It's 6.25. Let's look at a little bit, not really a more interesting, but a slightly different example. So it says, what is the area of the circular region on the wrestling mat? So here we can see we've got this circular region, and then we see that this distance is 32 feet. Well, that distance is actually the diameter. The diameter here is 32, so the radius is simply half of the diameter. So it needs to be 32 over 2, which is 16 or 16 feet. So now to find our area, that's what we're asked to do, find the area of the circular region. We're going to use our formula area equals pi r squared. So that's going to be pi times 16 squared, which is 256 pi. Now I'm going to go ahead and figure out what that answer is in terms of a decimal. And I get 804.248, and that would be feet squared. So there's your answer. That would be the area of that circular region. Okay, so now let's focus on what we call a sector of a circle. And a sector of a circle, I just kind of like to think of that as it's a piece of the pie. So like this green piece, or a piece of a pizza slice, if you want a pizza slice. That is what we call a sector. This is what we refer to as a minor sector because its measure of the arc, or the central angle here, is less than 180 degrees. So let's just, for sake of argument of this one, let's say that it's a 50-degree arc. That would be what we would call a minor sector. The yellow region is what we would call a major sector. So here we have theorem 10.12, and this is how we calculate the area of a sector. And the area of a sector is very similar to the area of a circle. It's just now we are only using a fraction of that circle. The total distance around a circle is 360, so then you just need to figure out what the arc length is and divide that by 360 times pi r squared. So let's see that in an example. So here we have a circle, and we are asked to find the area of this sector here in the shaded region. We know that the radius is 15 centimeters. We know that the measure of arc GH is 72 degrees. So if we want to find the measure, or the area of the sector GPH, it is simply going to be the measure of the arc GH divided by 360 times pi times the radius squared. And by the way, the radius here is 15. Go ahead and erase that part right there. So this is going to be 72 over 360 times pi times 15 squared. And it says leave our answer in terms of pi. So I'm literally just going to let my calculator do all this work. 72 divided by 360. And then times that by 15 squared, and I get 45 pi, and this would be centimeters squared. We're leaving it in terms of pi, and the units here was centimeters, so that's why I picked centimeter squared. And that is the area of a sector. So we use this formula right here, the area of a sector formula. Okay, third and final piece of this lesson is segment of a circle. And a segment is different than a sector. A sector is kind of a piece of a pie. A segment is like this shaded region here in gray. It's this region over here. That's a sector. Or I'm sorry, a segment. Segment. Sorry, I said sector. That's segment. We could also have what we call a major segment, and we could have what's called a minor segment. A minor segment, again, this arc will be less than 180 degrees, whereas over here, this arc would be greater than 180 degrees. All right, last formula. How do we find the area of a segment? This is the hardest part. So if I'm trying to find the area of this shaded region over here, that's the area of the segment. Here's how we do it. We find the area of the sector, that's this, and then we've got to minus away the area of a triangle. Now I'm just going to give you kind of a hint on this. I'm going to forewarn you that this is tough. This triangle right here, the formula for the area of a triangle is 1/2 base times height. So you might need to know that when it comes to the area of the triangle. We already did the area of a sector. Remember, that is the measure of the arc, I'll call it AB, over 360 times pi r squared minus that will give us the area of the segment. So let's see an example of that. So we're trying to find this light brown segment over here. Remember, we're dealing with a segment of a circle. So what we have to do is we have to find the area of the sector and the area of the triangle, and then we need to subtract. So first, let's start with the area of the sector, which remember is going to be, well, in this case, if this is 60 degrees, then that arc is also 60 degrees. So we're going to do 60 over 360 times pi times, and it looks like the radius here is 18. We've got to square that. Again, I'm going to let my calculator do the work for me. I'm going to leave this answer in terms of pi. So I'm going to do 60 divided by 360, then take that times 18 squared, and I get 54 pi. So that's the area of the sector. Now I've got to, and let me go back, we just found the area of the sector. Now we need to find the area of the triangle. We're going to subtract those once we get that. We're going to get the area of this triangle first. So what I've done here, let me use a different color here, is now I've pulled this triangle out over here. Now I know that this angle here is, I know that this angle here is 60. And I know that this length is 18 inches. And by the way, if that length is 18 inches, this length is 18 inches as well. Oh, by the way, if those two are the same, then these two have to be the same. And if those, so these all got to be 60. Because these two have to be equal, and the whole thing has to equal 180. So that's an equilateral triangle, which is great. So that tells us that this is also 18 inches. So this is good. It's an equilateral triangle. Now we just got to figure out its area. And let's just do it this way. Let's do it this way right here. Let's cut that in half. So if that's 18, then this is going to be 9. Now we got to find the length of this guy right here. So let me draw this triangle here separately. This is 9. This is a right angle. This is 60 degrees. So now we got to go back and use that 30, 60, 90 stuff. And so this is going to be 9 square roots of 3. That's what this distance is right here, 9 square root of 3. That's the height. Okay, so let's find the area of the triangle. So the area of the triangle, which remember is 1/2 base times height, is equal to 1/2. Our base length here is 18. And our height, we just found our height, it's right there. It's 9 square root of 3. Again, I'm going to let my calculator do this, so that's going to be, well, I can do that in my head. 18 divided by 2 is 9. 9 times 9 is 81. So this is 81 square root of 3. And now to get our final answer, by the way, we haven't even done the sector yet. So to get the area of the sector, we need to take this answer minus this answer. So I need to do 54 pi minus 81 square root of 3. We're going to go to the nearest tenth. that's a 54 pi. I'm gonna write this clearly, and I'm gonna put this in my calculator. 54 pi minus 81 square root of 3, and I get my answer to be 29.3, and this would be inches squared. And let me just make a quick check to make sure I got that one right. I did. Great. It was a tough one, but that'll be the end of this lesson.